Hey everybody, welcome to the channel. Today's video I want to do an introduction to polynomials. Polynomials, how we can classify them, how we can put a degree on them, what's the correct way to write them, what is correct form to write them in for our final answer, and give us a nice little introduction to polynomials because there's lots of stuff we can do with them and lots of stuff you will be asked to do with them in an algebra class. So first off, I just want to talk about the different types of polynomials, how you can classify them. Because a lot of times in a textbook you will be asked to classify a polynomial. And I've got the 4 different types listed here. The most basic is called a monomial, right? You can see I've underlined mono, the prefix to the word. Anytime you see mono at the beginning of a word as its prefix, that means one. A lot of kids in my classes have said, hey, one of my brother or sisters had mono and they were sick for like 2 weeks. Okay, yeah, that's true. That was usually short for mononucleosis. A monopoly is where one person holds all the money. Most people in the United States practice monogamy. They're in a relationship with only one person. There's lots of words that have mono. Someone who speaks in monotone. In a monotone voice, they don't have a lot of inflections. There's just one solid tone all the way through. And so in polynomial terms, monomial means you only have one term. Now, what is a term, right? If you don't even know what a term is, this is going to be hard to understand. A term is a part of an expression that is being added or subtracted, right? Adding and subtracting separates one term from another. And so up here on all of these, there's no adding and subtracting except for the end, but I'll talk about that in a minute. So the number 10 is just one term. X times y, that's multiplying in there. That's just one term. 4 times x squared times y, that's all one term. Even up here where they try to trick you by giving you a fraction, do you see any adding or subtracting up there? No, this is being multiplied. There's fractions way of dividing. That's all one term. The only time they will be kind of tricky to you is if they put something in parentheses or another type of grouping symbol, maybe a bracket, right? This is still just one term, right? Even though it is in a parentheses and you're like, well, wait, there's 2 things being added there. There's an x squared and a 6. No. If it's contained inside of a grouping symbol like a parentheses, that's still just one term. Okay, so those are monomials, not monomiles. A lot of kids will try to pronounce monomile when they first see it. Monomials. Binomial obviously means 2. You have 2 parts that are being added or subtracted, right? So here you have x squared added to 6. See how this is different than the others? There were no adding signs up here until you got to the parentheses on that last one. So we have the x squared, which is the first term. We have the 6, which is the second term, right? One thing that my kids have liked to do in the past is they like to draw a little kind of dividing line. In our school, we have like a wall, kind of temporary wall you can roll down to separate girls' PE and the boys' PE. And so what I've had kids do in the past is draw this little divider anytime they see an adding sign or subtracting sign to kind of help them visualize, okay, here's my first term, here's my second term, and then I've got it split, right, into boys' PE, girls' PE, the 2 different sides, right? So there's your first term, there's your second term. This is a binomial. Same thing here. 15 is your first term, and then there's your second term. 2 terms, binomial. Trinomials are going to have 3 terms. Obviously, the prefix tri meaning 3. There's usually, when you're in an algebra class, you'll usually have something that's squared, something that is to the first power, and then something that is just a plain old number called a constant. They don't all have to have plus signs, right? You can have here, then we have one plus sign and one subtracting sign, but you still have 3 pieces that are being added or subtracted. Those are trinomials. And then polynomial, the prefix poly means many. Anytime you see P-O-L-Y at the beginning of a word, it means many. Polytheism are people in their culture who believe in many gods or many supreme beings. Polygamy would be a culture where you can marry many wives or husbands. Some cultures in the world allow you to marry more than one person. But in math anyway, polynomials mean you have many terms. And so like I drew an example here with 4 different terms, right? Here's my first one. Here's my second one. Here's my third one, the number 12. The fourth one is this entire fraction, right? And so I usually get kids who are like, well, is that a quadnomial? Because I know quad means 4. Well, quad does usually mean 4. But when we're talking about polynomials, usually you just go to 3. And then anything higher than 3, you just call it a polynomial. So there isn't really a quadnomial or a pentanomial or an octanomial or anything like that. Even though that does sound kind of cool, you don't really have to do that in this. Usually mono for 1, bi for 2, tri for 3. Anything higher than 3, just call it a polynomial. And actually, all of the things up here are also types of polynomials. So polynomial is a really broad term that can be used to describe almost anything you write in a math class. But those are the 4 different classifications if you're ever asked to classify your polynomial. Okay, let me switch out my board because now we want to talk about the degree. A lot of times in an algebra class, you'll be asked to find the degree of a polynomial. And it's not too difficult, but it is a little bit tricky if you've never done it before. Let's start with monomials. You can see on this board, I have no addition, no subtraction. There's nothing splitting these terms up into multiple terms. These are all just one term. And so here's how you find the degree of a monomial. You add up the exponents on the variables. Only on the variables. That's very important, right? Only on the variables. So we'll start out pretty simple. Here you have 2 variables. You have 4th power and 2nd power. You can add those up. 4 plus 2 is 6th degree. So I would call this a 6th degree monomial. I'm not going to write the word degree on all these because that'll take too much time. On this second one, don't get fooled into counting this, right? This is not a variable. The variables are the letters, in case you're not that confident in what a variable is, right? So you're only adding up 5 plus 4. This would be 9th degree. Then number 6, you're like, okay, well, wait a second. What if there are no variables? I don't have any x's, y's, z's, w's, anything like that. If you don't have any variables, you don't have a degree. This is 0 degree, right? 0 degree, and that's okay. This one is a fraction. Don't let the fraction fool you. You still have 2 variables, right? You have the w, which is the 5th power, the y. This will fool a lot of kids right at the beginning. They think, oh, this is 5th degree because I just see a 5 there. No, 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 no. Anytime they don't put it an exponent, that's an imaginary 1, right? So this is 5 plus 1 right here. This is the 5 and 1, 6th degree on that one. If there's a negative, don't let that throw you off. You're still just focusing on the variables. Sometimes I like to put that 1 in there so it's not imaginary. I can really see it. 2 plus 1 plus 3. That is 6th degree as well. I've got a lot of 6's on this one. I try to trick people on this one. Every once in a while a book will get like this, and they'll start putting a symbol in there, like a pi symbol. Okay, hold your horses. Is the pi symbol a variable, right? Does pi ever vary? Does pi ever change? No, pi is always the same, right? Pi is a constant. We always know what pi represents. It always represents 3.14, blah, 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 right? So pi is not a variable. So you don't have any variables on this one. These are both constants. We know what the number 3 is. We know what the pi symbol is. It never changes. So we don't have any variables. If you don't have any variables, just like over here, the degree is 0. Up here, now when the book or the teacher or the test, whatever, tries to get really tricky, they will give you exponents on the coefficients, right? On the regular numbers. They're going to try to get you to add 2 plus 3 plus 2 plus 2. Nope, you're not going to fall for that, right? It's only on the variables. That's why I've underlined that. So you're only looking right here. Don't get distracted by that. That's not there for anything when it comes to finding the degree. You're just going to do the variables. X is to the 3rd power, y is to the 2nd power, z is to the 2nd power, 3 plus 2 plus 2. That's all you're doing, right? This is 7th degree. Same thing on here. They'll try to get your attention diverted with these parentheses and a negative sign. They really want you to focus on that. Don't fall for it. You're only going for the variables, the x's, the y's, the z's on this one. 3 plus 1 plus 4, right? 8th degree. And then my last one, I tried to make it even trickier with a fraction. I've got an exponent up here on the 5. Don't let that bother you, right? You have the w, you have the y, you have the z. That's all you're adding, and you get 4th degree. Okay, so that's how you find the degree of a monomial when there's only one term. Pretty simple, right? Most people are like, oh yeah, I can do that. Okay, now what if it's not a monomial though? Let me switch my board. I'm going to switch it out for this one. What about if they give you a binomial, a trinomial, right? Something that has lots of terms. And sorry, my marker kind of faded there. If you have more than one term and it's not a monomial, it gets a little bit tricky, but we can do it. What you want to do is you want to find the degree of each, my marker faded, I touched it there with my fingers, of each term individually, and then choose the highest one as your representative for the entire statement, the entire polynomial, right? So in most schools, you have elections to represent you know, your student council representative, or in our school we do a good citizen, right? And so what I try to emphasize with my kids on this is you don't want to do the whole thing, right? On this very first one, you don't want to do 2 plus 1 and say, okay, this is third degree. Nope, that's not how it works. You're just going to do each term individually, right? So this is a trinomial. We have 3 terms. My first term is right here. What degree is on that term? Okay, that is second degree, right? Because I've got the second power with my x. Here's my second term, 4y. What degree is that? Well, the only variable is the y. It's to the first power, so that's to the first degree. And then my last term is the number 6. It's to the 0 degree. And so I have second degree, first degree, 0 degree. I don't add them all up. Look what I do. I find the degree of each term, and then I choose the highest one to represent it. Just like the person who has the highest amount of votes gets to be your student council representative, the term that has the highest degree gets to represent this entire polynomial, this entire statement. And so my highest degree was right here. It was the number 2, and so I would call this second degree trinomial, but it is a second degree. Okay, let's do another one just to see, because this is kind of confusing sometimes for kids. On this next one, I have 2 terms. The x is squared and the y is to the 4th power, so I'm just going to do this term all by itself. And by itself, 2 plus 4 is 6th degree. And then my second term is right here. I have 3. The y has an imaginary 1 on it. I'm going to write it in there so I don't forget about it. 3 plus 1 is 4. Okay, so my answer is not 10. Don't you dare add those together. You just pick the highest one. The highest one is 6. 6 is higher than 4, and so this is a 6th degree binomial because it has 2 terms. Down below, my third one, the 16, has no variables, and so this is to the 0 power, or not the 0 power, the 0 degree. The w is the only variable I have, and so that is to the 1st degree, and so I have 0 degree and 1st degree, and so the highest one is 1st. That is a 1st degree binomial. Up at the top, here is your adding sign that's splitting it into the first term and the second term. Your first term right here, the only variable is the x. It is squared, so that's second degree. And then this 18w squared yz, I'm only going to add up the exponents on the variables. 2 plus 1 plus 1. That's the 4th degree. And so second or 4th, I just pick the highest. This is obviously 4th degree because 4 is higher than 2. 4th degree binomial, right? Because there's 2 parts. I threw in a couple trinomials at the end. This is 2.5. My decimal kind of bled into my 2 and my 5. But the first term right there is only the 1st degree. This term is 2nd degree. This term is 1, 1, 1. Actually, 3rd degree, it's if you get in a hurry on these, you won't even count those, and you'll think, oh, that's degree 0. No, no, no. Remember, you got to put that imaginary 1 on there. It really helps you visualize it, and it helps you not forget about it. Because if you're like me, you get in a hurry sometimes. You're like, oh, these are easy. I can do them so fast. And the next thing you know, you make a silly mistake. Okay, the final one on this board. I have a trinomial, right? There's 3 parts being separated by my adding sign. In this case, I have 2 adding signs. There's term number 1, there's term number 2, there's term number 3. What is the degree for each one? That's 2nd degree. This is also 2nd degree. And the y is also 2nd degree. So every once in a while I'll get a kid who's really thinking on their toes and like, well, what happens if they're all the same? Or what happens if you have a tie? Well, nothing to worry about. You just call it 2nd degree, right? They were all 2nd degree, but that's okay. The highest amount we had was 2. And so 2nd degree is what we're going to go for on that one. Okay? So that's very important. Only add up each term individually and then choose the highest term to represent the entire statement. Okay, I'm going to do one more board and then we'll be about out of time. This is about to be a 20-minute video, and obviously I don't want to make this too long. My final board. All right. Writing in standard form. Now, there is a correct order to write these, right? And I apologize, this green marker doesn't show up very well. I may not use this green ever again. If they ask you to write it in standard form, like what in the world? Standard form, I don't know what that means, right? Standard form is where you just rearrange the terms in order from highest degree to lowest degree. Now, there's a fancy word for this, and sometimes 8th graders don't know what this word means. Descending, right? Descending means you go from highest to lowest. And so when they present you with a statement like this and they say, hey, write it in standard form, you're like, excuse me, I don't know. I'm trying to solve, there's nothing, well, I don't understand, right? when they want it in standard form, you just find each degree, each term, just like we did on the last board, right? This is first degree. This one is second degree. And then the 8 is to the 0 degree, right? And so you just need to go in order from highest to lowest. And so the second degree is the highest term I had. Second degree gets to go first. And then first degree, that 4 is positive, so I'm going to put a plus sign. And then I'm going to do 4W. And then 0 degree always goes last. And it's basically just rearranging it, right? Just putting it in the right order. So let's look at the next one, right? I have 3 terms on this one. This term is to the 3rd degree. This term is to 2 plus 3. That's the 5th degree. I'm going to put little notes down there for myself. This term right here, it's a letter K. That's a different letter, but don't let that throw you off. It's still to the 2nd power. And so the highest degree I had is 5. 5 should go first. This whole term goes first. And then my next highest is 3, so I'm going to do 3rd degree, 3x to the 3rd. And then my last one is 2, and sorry, my handwriting's getting kind of sloppy there. 16k squared is what that says. The last one on this left-hand side, the -4 is to the 0 degree because there's no variable. This is to the 1st degree because the w is to the 1st power. This is to the 2nd degree, right, because the z is squared. So this needs to go first. Now don't forget, it's really easy. Whatever symbol is in front of it, like here, the minus sign that's in front of it, is part of that term. So this should be -5z squared. Kids that aren't really paying attention will just put 5z squared. That negative sign is a part of it, right? And same thing with the 8. Right in front of the 8 is a plus sign. So that should be plus 8w. And you can put the 1 on there if you want. It's really not a big deal. And then the 4 has a minus or a negative in front of it. That's going to go last because that's 0 degree, right? So this is standard form. Put it in order from highest degree to lowest degree. Okay, my last couple ones. I tried to get a little bit trickier, right? Here is 1, 2. That's 2nd degree. Whoa. This is to the 3rd degree. This is to the 1st degree. So you have 2, 3, and 1. Out of all those, 3 is the highest. 3rd degree, x to the 3rd. It's positive. That goes first. And then this is 2nd degree, and it's positive. So I'm going to put xy. And then this minus y is 1st degree. That goes last. So you have 3rd degree, 2nd degree, 1st degree. Boom, you're done. Okay, final 2. This w is to the 1st degree. The 10 is to the 0 degree. This is to the 5th degree. So 5th degree is obviously going to go first. That's a lot higher than 1 or 0. It has a subtracting in front of it. So don't forget, this whole thing needs to be first. W to the 3rd, y to the 2nd, with a negative sign in front of it. Some people get really hung up. They're like, well, wait a second, I thought this was subtracting, and now it's a negative? Yeah, don't let that hold you up. It's just kind of how it goes. Over here, this is 1st degree. It's a positive 5. There's nothing in front of it, so since it's positive, I'm just going to put a plus. And then the 10 has a subtracting with it. It's 0 degree. That goes last. Standard form is complete on that one. And then the grand finale. I had a student who asked a really good question the other day. What happens if they're all tied, right? This is 2nd degree. This is 2nd degree, right, because 1 and 1. This is 2nd degree. What do you do if it's all 2nd degree? Is there an order? Or, if they're all tied, is there a way you're supposed to do it? And what I say to them is usually if they're all tied, someone, unless they're being really picky, they probably won't get too mad at you no matter how you do it. But if you want yours to look like the answer book, if you want yours to look like you're a real math genius, a real mathematician, you'll go in alphabetical order, right? And so since these are all 2nd degree, what order should I go in? I should probably go alphabetically, right? So the letter A, which is the first in the alphabet, should come first. It's just an A all by itself. And then A with a B should come next, and then the B, which is all by itself, should go at the end. So this is how most math books, how most answer sheets, most math teachers would want you to do it. If you have a tie, you just go in alphabetical order. Okay? And that is standard form from highest degree down to lowest degree. One other thing they may ask you, and I'm just going to throw this in here. Sometimes your textbook will ask you, hey, what is the leading coefficient? Right? Leading coefficient just means whenever you have it written in standard form, what is the very first number that your variables are being multiplied by? So like, for example, on this one, when I had it in the correct order, see how the 4 comes at the very beginning? That 4 is the leading coefficient, kind of like the line leader when you're in elementary school. What's at the very, very front of the line? And it has to be a number, right? Like up here, A coefficient has to be the number that the variables are being multiplied by. So like here, the coefficient is 1, right? The leading coefficient is 1. If there's no number in front of the variable, down here, it's -5, right? -5 is the leading coefficient. On this one, here's another one where the leading coefficient is 1, since there's no number there. Here's another one. This is -1, though, the leading coefficient, -1. And then on my grand finale, this would also have a leading coefficient of 1. So if there's no number, it's an imaginary 1 or -1 if there's a negative sign. But if there is a number there, you always go with that. Okay, this video is 20 minutes. Thank you so much for watching. If you're a student in my classes, I'm going to put an assignment up on the class website that you can practice some of these. It'll be a practice assignment, so there'll be videos there if you want to get some more explanation, or you can pause this, rewind this, go back and watch it some more. Thank you so much for watching. I appreciate your time. I appreciate your patience. I know this was kind of a lengthy video, but there's just a lot of stuff when you're talking about polynomials and trying to introduce it. So I'll be back tomorrow, and we will try to add and subtract these. But for now, thank you so much, and have a good day.